Om Shri Gurubhyo Namaha. As a tribute to Sri late J.V.R. Sharma sir, founder of Tapovan School, a tech-savvy person, we have taken up this initiative to host the hybrid version of conducting orientation on drones for the benefit of all the South Zone, our ATL students. And it's my honor and privilege to introduce Sri Deepesh Goyal, Regional Mentor of Change Karnataka with ATL Innovation Mission, Niti Ayog. He is a tech veteran turned educator with 25 years in the industry, now dedicated to education for the last 8 years. He led MNC business in 3M, Danaher, Fortive, Tyco Electronics, and GE, and did consulting on industrial IoT and taught middle classes in a government school for 2 years as a Teach for India Fellow. He is a published author and alumnus of BIT Ranchi and IIM Calcutta. Currently, he is doing freelancing projects on generative AI to develop various LLMs and also doing idea to product development for his educational social enterprise. We are all really privileged to have such an eminent person to take over the proceedings. So I request Mr. Deepesh Goyal to give us an inputs about the agenda of this mission. Thank you, sir.
Good morning, everyone. I am Deepesh Goyal, and thank you, Vani ma'am, for an excellent introduction. I am blessed to be here at Tapovan School, which is down south in Bangalore. It's very near to the Bannerghatta National Park. I'm sure you all would be knowing that, and you would have visited once that place. So this school is located just about 5-7 kilometers from there. So this session is exclusively on drone making, and this orientation session is done by Kishore. Kishore is from Kalpin Tech, and this is our value-add partner in our ATL Sarthi initiative. And this month, if you look at February month, create your own drone is the theme for ATL Innovation Mission, and this is what we expect the students to do. I'm sure that all of you have exams on your head, so rather than doing this, we should have actually done some pariksha pe charcha. But no, we are following what ATL Innovation Mission has asked us to do in this month, and this is a very important session because drone is becoming very popular in the country as well in the world. And I'm sure you must have come across India-Pakistan war, where a lot of drones were flowing across the line of control. And we did an excellent job in terms of using the drones and making the enemy not come to our territory and do any harm to us. So that's the power of drone, and today it is not just used for that purpose, but it is also used for last mile logistics and so many other great purposes. Sometimes it is also used for destruction. So recently there was a Irani drone which was shot down by a US Marine. So these kind of a thing which is something that it has to be handled with care. So that you have to keep in mind. So with that in perspective, I'll just give you a brief introduction about Kishore sir. So as I said, Kishore sir is a mechanical engineer by qualification with masters in energy management. He has over 22 years of experience in UAV systems. He initially worked for Honeywell and plunged into entrepreneurship in 2007, founding Drone Aerospace System, in which he has designed and built many types of drones that operate in air, on ground, and even underwater. He has won many awards at the national and international level. In 2018, he founded Kalpin Tech Private Limited and is today a leading supplier of indigenously developed wireless communication devices used on Indian defense drones. So with this, I would like to hand over the mic to Kishore sir. Welcome.
Hello. Yeah. Thank you, Deepesh sir. Thank you for the warm introduction. So, as part of ATL, we are doing this drone session over here. This is the first session that you're going to be having, which is basically an orientation for understanding the area of drones. So you're now getting introduced to drones in some way. We will be only starting. There is a lot of detail. It will all get in as you go further. It all cannot be covered in one, but let's begin. So let me first ask you one question. What is a drone? Okay? What is a drone?
Drone is an aero vehicle which can run even in land, water, and even in atmosphere, sky.
Okay, good. Anyone else want to answer what is a drone? Okay? Yeah?
Which runs over land and pilot bringing the call.
Okay, good. Anyone else? That's fine. But let me tell you what a drone is. A drone is a male honeybee that does not do any work. That's what a drone is. So let's get into a little bit of history of something about drones. Let's start with a little video.
Ever since man started to think, he's wanted to fly. But flying was strictly for the birds. And continued to be so for thousands of years. Man, eternally optimistic, kept trying. Encouraged by his many successes, man kept trying. Through his genius and his inventiveness, he managed to get his machines off the ground. And sometimes he brought them down again.
So those are the various attempts that have been there of trying to fly. Man has always wanted to fly. But there's a lot of history to drones actually. There's a lot of history to aviation. There are models of what is today like a modern airplane. This have been more than 1,000 years before. The models of which are found in archaeology. So we don't really know the details about all those. But the fundamental thing that we consider in modern history, because we have evidence to, is the Wright brothers. The Wright brothers are basically two brothers who for the first time made a sustained powered flight. People have been flying like different ways, gliding and everything. Powered flight is where you're able to rise from the ground. So that is the first time that was done by the Wright brothers. And that's basically the first time that we actually ever come to modern flying in aviation today. So now again, what is a drone? You're right. Drones in the context of today's times are basically these autonomous systems, but they're not necessarily vehicles. That is though our focus here will be on vehicles, and in that further aerial vehicles, particularly drones are not. That camera that is now following me as I walk here, you can see that camera moves along automatically where I move. If anyone's noticing that. That is a drone too. Autonomous systems. Basically, that is the fundamental idea of what is a drone. So any system that is operational by itself is what makes it a drone. So these are the various types of drones that you're seeing over here. You will see variety of drones that you're going to be seeing. We are, let's start a little bit of different types of drones over there. Ground vehicles, you see this vehicle over here? This vehicle is also a drone. This was used in a particular event which was basically conducted by the Indian and the US Army together. It was a joint exercise that was done by the Indian Army and the US Army. I'll show you a little video from this. It had a launcher, this one doesn't, but you see there's a vehicle that is carrying the drone, the aerial drone that you people are familiar with, that is that one over there. It flies, but it takes off from the ground vehicle. So the ground vehicle is also part of the system over there. So the ground vehicle navigates. This was an era, this is a situation wherein ground vehicle is actually very efficient. You can actually take it to long distances, far away with extended periods of time without losing a lot of energy. A drone aerial drone consumes a lot of energy. So that is the primary difference. So therefore, ground vehicles also have a role to play in our defense systems. In this particular case, the situation was a terrorist situation where the ground vehicle goes within about 1 kilometer of the hostile region. Like, Mumbai terror attack happened. Let us say that you cannot go very close to the building over there. This ground vehicle will go very close to the building, as close, maybe within 200 meters or something. The air vehicle will take off from that and then go into or nearby to the building. That is the basis on which this program was done, and that is how that worked. Ground vehicles are also, just because you see a ground vehicle, it need not always be on wheels. You see this wheels?
Good. Right, it's sorted out now. What had happened? Calibration improved. How did you do? Averaging.
You see that? Do you want to see that in action? Do you see this? That what you're seeing on the screen is also over here, similar thing. You can go front, go back. And it can go to sleep. So let's look at now underwater vehicles also. That we don't need this guy anymore, do we? I'm turning on and off this thing with a magnet. You know why? Because this thing can't have ordinary buttons. It's because I haven't told you another superpower that that robot has. It can go underwater too. So how many of you think that can swim? Have you seen it swimming? So this is basically an underwater drone. So when we are talking about drones in the context today in military, it is extremely important that while our focus is all on aerial drones, there is a very, very important program and desire and action that's happening right now in the space of underwater. And here is something that I want to bring all of your attention to. Most people, when they imagine drones, they only think of the air vehicle. But there is a very, very important role that the drones play underwater. Do you know where our Mumbai terror attack, when it happened, 26/11, do you know how those people came to us, the terrorists? They came underwater. So when we need security even underwater. So this particular drone was done for the Indian Navy. The application is something like two things. Whenever you have a boat or a ship or anything coming towards our shores, you have this robot that goes from the beach into the water, checks under the ship as well, under the boat, because you know divers will be there hanging to the boat under the water, and then they can come later when it is safe for them to come onto the shore. So this basically scans the hull of the boats. Tomorrow it can be even weaponized, wherein if you like, it can go have harpoons, other things that you can shoot if necessary. All these things are going to be a part. So when we say drones, there is going to be air. There is actually a very, very neglected field of drones, which is the underwater drones. And there is a huge opportunity. If everybody is fighting and competing today for aerial drones, there is a huge opportunity for all of you as entrepreneurs or ideas, creations to actually fight in the space of underwater drones. And I think you need a lot more to be innovated in the underwater space because it's highly neglected. I'll give you one example. How many of you know Archimedes' principle? If I have to make something go underwater, how do I make it go underwater? Or how do I make it float? It has to go underwater when you need, it has to rise up when you need. How does a submarine work? How do you vary the density of a body? How does a submarine?
Submarine has two tanks within it. When it is to go underwater, the tanks are filled with water. So the density of the submarine basically increases than that of the water. So it sinks basically. That's what the principle.
Absolutely right. With one very minor variation, technicality. you're varying the volume of water displaced. When you say you're not actually changing the density, it is effectively the density also, because you're changing the amount of water displaced. So when you change that, you know what happened to us when we did this? There is two kinds of balancing. You can make the density fixed in such a way that you know that it will be at a particular level of water. Like an egg, you put it in water, it floats in the middle, that kind of thing. But we did all these tests. You're seeing all these things now, no? It is in the swimming pool. Swimming pool is what water? Nice fresh water, no? What is the density of fresh water? Approximately 1 kg per cubic meter, 1 liter, 1 ton per cubic meter. So approximately, that is the density of water. But when you go into the ocean, it's salt water. Salt water is denser. So what happens when this thing, which you so beautifully swim in the swimming pool, when you take it into the shore, when we take it into the ocean over there, it will just sink. Or sorry, it will float. It will float. So what happened? Even more interesting. Now, you take this thing, you've tested it in the swimming pool, it's worked beautifully, it is floated to the 1 meter below the water, everything. Then you take it to Bay of Bengal, you go to Mangalore beach, and then you try it over there, it works little bit to tweaking because it is floating, you adjust it slightly, you say it's very nice. Then next you take it to Vizag, Bay of Bengal. From Arabian Sea, from Mangalore, you take it to Bay of Bengal. Again, you take it over there, what happens? Again, it floats. Because the density of water is also not uniform. The amount of salt content that is there in Bay of Bengal is different. The amount of salt content that is there in Arabian Sea is different. So therefore, you have variation density. So you need to get this balancing and all very, very precisely done when you are doing all these things. Lot of opportunity there for actual innovation to be done for this. So underwater, there are many other things also. We were also working on something like this, which we didn't actually get to do it. So I'll just show you the video of it. It's so we have to create a machine that will basically look and feel like one within the ocean itself. So we mimic a fish. So this. So anyway, so that is for underwater and ground vehicles, which are also very important, but you know that we are largely focusing on air vehicles around here. So let's get to air vehicles. How many types of air vehicles do you know? How many types of air vehicles? Yeah?
Narrow drones,
Okay.
small drones,
Okay.
big drones.
Okay, that's by size. Anything on type? Yes? Okay.
Aeroplanes, jets, helicopters.
Okay. Aeroplanes and jets, what's the difference?
Aeroplanes can take many passengers as well as jet can take just 2 and they are used for defense.
Okay, that is fine. So, how many of you have observed in nature? What does nature do? How does nature fly?
Feature.
Hmm?
They are streamlined bodies,
Hmm.
so they can fly easily.
So when you have seen drones, you have seen mostly like this, right? Hmm? Have you ever seen something working like a bird? So this is a flapping wing drone. Just like how I showed you mimicking underwater, this mimics in air. You know what happens when these flapping wings drones, when we fly them in the real world, you know what happens to them? The first thing that will happen is the birds in the sky, the real birds, they start attacking it. Because they think that some competition has come for them. Who is this? What is this new thing that flies?
Yeah.
So this is another multi-rotor system that you're seeing. All multi-rotor systems don't have to look the same. So this looks like one crown on somebody's head. So there are multiple types of systems that you're going to be seeing. Now we'll So now let's get into the little slowly start getting understanding a bit more into detail of the types of air vehicles. Let's first classify them by structure. Lighter than air. How many of you understand what is lighter than air? Yes? I see the one hand always coming up here. I'll take your question this time. Your answer.
So basically, drone is lighter than air means it's more less like denser than air.
Less dense than air.
Yeah, less dense.
So you're played with balloons, right?
Yeah.
So balloons, normal balloons, if you blow with your mouth, they're very light, but they fall down. But when you go in those carnivals and then that person with one gas, he fills that balloon and he gives, it is flying up.
Yeah.
What is the difference?
Because in that, there we use helium,
Mm-hmm.
and but here normal electricity. So like there's difference between the density of that.
So helium is lighter.
Yeah.
So therefore so now do you think you can actually make a drone with something like helium?
Might be.
You can? It is possible. In fact, some of the oldest systems that we have work on that principle. And that's also one of the important differences of what the Wright brothers did. We actually had flying systems, which is basically lighter than air systems, before the Wright brothers. So they were balloons that used to be used for flying. Those kind of systems were already in existence. The first time what Wright brothers achieved was basically something that is heavier than air. So you have something heavy and yet able to fly. That's one of the achievements of Wright brothers. In fact, there used to be transportation systems, like how you have aeroplanes right now. You had aeroplanes, aerostats, basically. These air vehicles that are based on these balloon type systems for passengers. So the hundreds of people will sit in that. You see this picture to the right here? Under that big balloon is basically a cabin where about 20, 30 people would actually sit. The balloon would be, this airship would lift all these people, and then you would actually go from one city to another city. So it would be nice to have something like that now, no? So there are, but now it is very exclusive. You know why? What happened at that time? Yeah, you can be louder, it's okay. You know what happened? What did they use? What gas did they use to fill that? They used hydrogen. Hydrogen is a very light gas, so it was most efficient in terms of getting this for the smallest volume that you are able to lift the most number of people. So they used hydrogen, but then hydrogen is explosive. It's inflammable. So there was once a fire accident and a lot of people died, and ever since then we have not had commercial balloon-based flying, except for this left side, which is hot air balloons, the ones that are there on the left side now. This is still mostly recreational. You don't have it for transportation. So, shall we get to fixed wings? What is a fixed wing aeroplane? Pardon? They won't flap, all right? So, do you see this? See this model? This is a fixed wing aircraft. In the classification of drones by the structure, you have these fixed wing aircrafts like this kind. Then you have multi-rotor systems. You probably have seen this. You have single rotor systems. How many of you know this helicopter? Nowadays, nobody wants to look at this for drones, no? Nobody has seen this, nobody uses this for drones. This is a tri-rotor. It has 3. So, what is the difference between all of these things? Can anyone tell me what is the primary difference between the fixed wing and the multi-rotor systems? Or any rotary systems?
Consumption of power.
Okay. So when you say consumption of power, what is the difference? Can you elaborate on that?
Different drones take different, consumption of powers. Some lighter takes less and heavier takes more.
Oh. Okay. So which is more efficient?
So basically what happens is in rotor drone, which has 4 wings, the last 2 rotors, they move anti-clockwise, and the front, they move clockwise. So through air difference and through Bernoulli's theorem, they uplift and then they move. And in tri-rotor drone, the last one, which is at the back, the front point, that moves anti-clockwise, and the 2 other rotors which are there, they move anti-clockwise. It works like that, and that's how.
Okay, so we'll get to that. That was more like for later, but we will get to that as well. In fact, I will probably show you something for that as well. So the fundamental difference between a fixed wing and a multi-rotor is basically the way the propulsion the system works. In a fixed wing drone, you have a wing. The aircraft that you see, it has 2 wings, the left wing and the right wing. Now, what happens is that this left wing and the right wing basically are what is known as an aerofoil. How many of you know what is an aerofoil? Don't understand what an aerofoil is. Okay? It is an optimized shape, but that's immaterial. When you were a kid, maybe even today, I don't know, if your still child in you is still there, when you're in a fast-moving car or in a train, you put your hand out of the window. Have you tried putting your hand out of the window? What happens? And then you put your hand, you do this. Have you done that? How many of you have grown up, or everybody is in AC cars and AC trains these days? Have you ever done that? Put your hand like this in the wind blowing so fast, then you take your hand like this, it goes off. It keeps going up. Right? Have you experienced that? Okay. So your hand is also a kind of an aerofoil. The most basic aerofoil, the most basic wing is basically a flat plate. It's a flat plate. So when you have this flat plate and you have air blowing into this, depending upon this angle, the amount that the wing will lift, the aerofoil in this particular case lift, will keep varying over there. You would have experienced this in your in those plays that you are doing. As you keep it flat in the direction of the wind, you will be stable. If you do slightly this way, it will go down. If you do slightly up, your hand will go up. You'll be pushed up. I can actually even show you that with a little blower and a piece of thermocol over there. So, among all these things, to be remembered, to be understood for you, is that the relative motion between the air and the wing is what is finally important. Everything is it is relative. You can have a aeroplane that is practically flying backwards when you see in the air, no? You will see it going backwards, but it's not actually going backwards. It's going forward with relative to the wind blow. But to the ground, it is going backwards. That means there is a huge lot of wind. So whenever you have a wind blowing and you have an aerofoil kept in the wake of the wind, depending upon the angle of attack, this is called as the angle of attack, depending upon what is the angle of that wing in front of this thing, you will have the amount of lift generated over there. Now like this, you will have many forces that are generated. You will have lift that is generated. You will also have the weight of the wing itself. The wing itself has its own weight, so it will be pulling downwards over there. Then you have the relative motion of the wind itself, which basically creates what is known as the thrust, but we'll not get to that. That's not important. The drag push. Whenever this wind is hitting this aerofoil, it's also moving backwards. So when you are putting your hand out of the window and then experiencing this lift, if you make your hand so vertical like this, if you bring it like this against the wind, it will only go backwards. It will not rise up at all. So when you keep on increasing the angle, at some point in time, there will be only drag, there is no lift, there is weight coming down. So all these parameters that you control is what will finally give you the lift and to the this. So when you look at this particular thing, you will see that if I hold it flat like this, the wing is slightly tilted back up like this. Do you notice that? If I'm holding it flat right now, you can see it over here. The wing is slightly up on here and then down here. It is slightly tilted like this. This is basically what is the angle of attack. This you have to tune it, you have to design it, all these things. We are not getting into the math right now, but all this is what will come into your design when you're starting to actually build your own aircraft. Just remember one thing, there are two things that you can do. You can get parts, you can assemble, you can build a drone. You can learn the subject and you can design a drone. Which one do you want to do? You want to design the drone. So let's get started. Okay, so we have this. Let us look at this with a little more detail. I mean, it's only an orientation, so we're not getting into the depth of all of these things, but let's look into this particular drone over here. I told you that when there is wind coming in, how is the wind coming in? Because of the propeller. All those we'll start analyzing later. There is a propeller over here, it will push forward, and that is how you have the wind relative to the wing that is there, and then you have lift generation, and this is how this stays afloat. But I have a question for you now. If, let us say that everything is normal, it is flying like this. How does it rotate like this? I mean, you know, no? If you have to fly, what do? When you turn your bike, what do? You bend to the left side. Then you turn to the left side. For the drone also, you will have to tilt like this. How do you tilt? How do you tilt?
Back propellers will be there.
Back propellers, there are no back propellers. There's only one in the front, right now not mounted, but there's only one in the front. How will you change the direction?
Clockwise and anti-clockwise.
How? Yes?
One side there are the two wings which are connected to the servo motors. When the wind blows in the forward direction, the servo motors bends towards that, then it turns over the left. Then when the right servo motor actives up forward, that transfers into right direction.
Good, but let's get fundamental. Now you told about how to assemble a drone. Now let's talk about how to design a drone there. If I told you about this experiment that you put your hand outside of the window and then lift is generated, your hand is moving up, right? Now in a real plane, you have two wings. So your hand is there on both the sides, left side and right side, the wind against the wind. You're at a particular angle, the whole thing lifts together, right? That's how you rise up. If I were to want to tilt this way, which is what the plane does, what should I do? I told you everything about angle of attack. What did I tell you? If your hand is flat like this against the wind, no lift. Slightly you raise it, you will have more lift. You raise it too much, you will have no lift and you will have only drag. Slightly, you increase the angle, your lift will increase to an extent. Now, I told you that. Connect that to these wings of the aeroplane. If I have two wings like this and I need to tilt like this, what do I do? What do I do? So you're saying that one wing I will slightly increase. So if I have two wings and I want to go left like this angle I will slightly increase. This you will decrease, correct? If I decrease this slightly and increase this slightly, what will happen? Here right side lift is more, left side lift is less, so I will tilt, correct? You understood? What do you think happens on a plane? You know, there you call, what do you call this? Ailerons. On the wing, have you been on an aeroplane? How many of you have traveled by plane? Okay. Have you seen on the wings, at the back of the wings, you have these things that rotate? Like this. You have this movement that happens at the back of the wings. Have you seen that? What do you think I'm doing when I make this like this? I'm bending this wing like this. You see, this wing, this aileron, I'm bending it down like this. What do you think is happening to this wing? Two sides, you see. This side I am raising it. This side I am lowering it. What is effectively happening? What you said is happening. You said, no, bend the wing slightly. I am literally, practically changing the angle of attack of this wing. I am changing the angle of attack of this wing. So what is happening? There is, when this is the position like this side is generating more lift, this side is generating less lift. Amount of lift that is generated. What will happen when this side is more than this side? Tilts. This is how you tilt an aeroplane. So this is the aileron system that you have over here. I do not have a traditional fixed wing here to show. It was a little too big to carry actually. So that's why. Otherwise you would find that in, I would have loved to show you that as well. So you have the two ailerons, you adjust the angles over there, you adjust the lift that will happen, and when the lift is imbalanced, you will have a bending, the rotation of the aircraft. You know what a multi-rotor is? You see these things? Ma'am, do you have a propeller here? It's available? Okay, no issue. I'll take this. Do you see this propeller over here? This propeller has an angle like this, you see? And there are two in this direction, like this. So when they rotate like this, you have the lift generated over here. You have this thing. So let me actually get to the helicopter. If you look at this helicopter, so this helicopter, when you see here, you see this, you can change that, you have the angle of attack that you can do. Isn't this propeller same as the wing that I showed you now? The wing that we described right now? Is this any different from a wing? What is a propeller? It's also wings. It's just oriented and operationally different. But it's also a wing. So now, what happens in this aerofoil is that as it rotates like this, over here, there is lift generated by either side of this propeller, and therefore you have the lift generated, which is rising this up. But let me ask you one question with regard to this. Yeah. That will go in assembly part of it. So you can, that is totally an electronics question. That is where you have a wireless connectivity between two drones that is there. You have a pairing system that is done typically, so that whenever I can talk to only one drone, so that if you are flying another drone, you will be able to control that independently. So it is basically a pairing, matter of pairing that happens. We will get to that part of it. So this helicopter that I told you about, when you have this rotation over there, in a normal plane that you saw, I am moving forward. So you are having both the wind flow, airflow that is happening on this and this equally. What did I tell you about the aerofoil? The amount of lift generation that you have is proportional to the speed of the wind also, right? It's proportional to the speed of the wind, right? So whenever you start moving forward, the airflow over there, you will have a lift generation. But what happens in case of a helicopter? Helicopter, now we'll get into more detail later, but if you see the helicopter over here, when it is stationary like this and this thing is rotating, there is lift generated across this entire the wingspan of this thing, and you have it flying like this. Just imagine what happens if I start moving forward. Okay? Now, think about this. Can you guess? You see, this is rotating. Okay? This is rotating. Now, when I am moving forward, which side of the wing is moving faster with relation to the wind? With relation to the wind. See, everything is relative. Everything is relative. Relative between the blade and the air. When I'm stationary, let us say that the air is not moving. Let us, like in this room, air is stationary. You have this rotating like this. So you have the whole thing, the air is like constant speed, so you have nothing over here. But when I start moving forward, what happens to the air relative to the blade? There is a motion, right? Air is in this direction. So when my blade is rotating like this, if my air is in this direction and I am rotating here, this side is seeing faster wind, this side is seeing slower wind. Can you imagine that? Do you understand what it means? If my helicopter wings are there like this, and if helicopter was moving stationary, then the wind would come like this. But if I am rotating like this, when one half of the wing will face higher wind velocity when compared to the other half. Now, what did I tell you about angle of attack and lift? When I said angle of attack, you increase the angle of attack, lift will generate higher. If you speed increases, lift will be higher. Amount of lift generated will be higher. Now here speed is increasing. On which side? On one side. So left side my amount of lift is higher. Right side amount of lift is lower. What will happen? When I told you about the aeroplane, what did I tell you? In the aeroplane, when I said amount of lift will be different between left and right, what happened to this? It turned, right? Now what will happen to the helicopter? It moves forward. The helicopter moves forward, but the lift is generated different between left and right side. Now what happens? What should happen to the helicopter? It should tilt, right? Technically it should tilt, right? But it doesn't. And why? It doesn't tilt. It will technically still work, but it will have a lot of rotational. Okay. What if a propeller is broken on one side? If a propeller is broken on one side, it will still work because the lift is generated, but the lift generation will be uneven and therefore you will have a whole lot of vibration. These are what we do as emergency procedures for landing and other things when there is such a situation. You will still be able to operate, but very, very harsh. So this helicopter thing again, back to it. Why doesn't it happen? Why I'm even talking about all these things is because you need to understand the evolution of why we are right now. You see the most common is this 4-rotor, no? 4-rotor drones. It's important to understand. If you have seen a helicopter, have you seen how complex this part is? You see the mechanics over here? Look at it. You can actually come, you can see all these things. You will see the details over here. Look at how many mechanical things are there. There are so many linkages over here. There is one rotation over here. There is this thing stabilizing. Why is all this needed? For solving the problem that you just told. You know what happens in a helicopter? In every rotation of the helicopter, every rotation of this propeller, when this wing is on the right side, you should imagine this. This thing is rotating at like hundreds of RPM, thousands RPM, maybe even say 1000 RPM it is rotating. When it is on the right side, on one side, the angle of attack is less. When it's on the other side, the angle of attack is more. So this thing, as it rotates, has to keep twisting. Because it is rotating around this thing. When it is this side, it has to be at one angle. When it is at this side, it has to be another angle, so that totally the lift generated will be equal by adjusting the angle of attack. And this twist generation that is there, how much angle of attack, will keep on changing as I'm moving forward. That means if I'm moving at 10 kilometers per hour, it will be one angle. If I'm moving at 20 kilometers per hour angle, it has to be more because the wind speed is changing. So the lift generation has to keep changing. Helicopters were the way of doing vertical takeoff and landing. Helicopters are among the most dangerous of air vehicles for us. In terms of its flight and its mechanics and its control systems and everything, it is an extremely complex system. Because of all this difficulty that I told, this head device itself is extremely complicated, prone to a lot of failures. So therefore, helicopters, you will have a lot of more accidents, all those things, because the amount of effort required in maintenance and everything is extremely high. Apart from that, it has very efficiency someone spoke about. It has the lower efficiency than a fixed wing. But helicopters are mainly used for one single big advantage. So many problems they say no with helicopter, but still we use helicopters. Why? Why do we use helicopters still? Why do we even have helicopters? The aeroplanes should be enough, right? Yes? Okay? Right. So it can do vertical takeoff and landing. That is the single biggest reason for us to use helicopters. It can lift off like this. You don't need a big runway. So today, tomorrow, when your politicians come, they will come here. This ground also they can land. You know, because you can do vertical takeoff and landing. You don't need a big runway. If you've been in an airport, you see so many kilometers one runway will be there for the aircraft to start. Because I told you, everything is relative velocity. You need to first become so fast on the runway. Then your wings will start generating lift, and then you will start rising up into the air. But for you to be actually able to do that with a helicopter, you don't need any runway. Wherever you are standing, you can directly lift off. So there are a lot of actually operational advantages for a helicopter, which what makes it desirable to have. But big trade-off was this complexity. Now enter the multi-rotor systems. The quad-rotor systems that we are having. This doesn't have any of that complexity. You see, no rotation, fixed. Everything is fixed. 4 rotors are there lifting, and it goes off. Okay? So we will get to more details about all those things also. But how many of you think that you have a fixed wing and you have a rotary wing aircraft? Two types of aircrafts. You have vertical lift and you have a fixed wing aircraft. How many of you think that they are two different things? Okay, so you have a fixed wing. Others don't think, or they don't know. Huh? Okay, so good. So you see that vehicle, that drone over there in the last? It's standing. It looks like a fixed wing, no? You see this? It looks like a fixed wing. But it's standing like this. Vertical takeoff. How many of you think that can fly? You think it can fly? How does it fly? How do you think it will fly? Like a helicopter or like a plane? It will fly like a helicopter. Okay? You want to see it fly? It takes off like a helicopter, vertical. Now it flies like a regular plane. Then it can bring it back into a vertical. And then you can land like a vertical plane. You know why that was not done before? This is not something great knowledgeable that today we have become so gyani that today we know how to do that, and we couldn't do it 100 years ago when they started this plane. You know what is the difference? Why that? We could have done helicopter like this, helicopter plus plane combination like that, but it was the problem. And the reason for that is where we come to unmanned systems. If you were sitting in that plane, can you imagine what would happen to you once like this, once like this? You will not be normal. When you come back, you'll be full headache, fall down. But now we are in the space of unmanned air vehicles. This fact that we are unmanned gives us flexibility with regard to risk taking. You can do high risky operations, which you would not do because you will risk the life of people. You will not do things that are uncomfortable. You can do that over here. You can create models of systems which are kind of wild in imagination of things. And I'm telling you, these are very, very normal systems. There can be very, very innovative drones that you can create as well. So this gives us a huge opportunity. With that, we just end the orientation part of this thing. We will get to a lot more detail. I'll be more than happy to take questions now. We will get into a lot more technicality, a lot more development and all as we go forward over here. But for now, I would like to know if you have any questions. Yeah. Any questions in the chats?
There's one question. If we change the battery, like in my drone, I'm using a small battery, and if I change it with a big battery, will it make a difference?
It will make a difference. If you change the battery from being a small battery to a big battery, the fundamental change that you're bringing into the system is the weight component. If you recall what I told you about the aerofoil, or this applicable for multi-rotors or fixed wings, you are essentially increasing the weight component. Your bigger battery is increasing the weight. Because your battery size does not determine your thrust or any other component in that. You're only increasing the capacity. That is the number of hours you can fly by putting a big battery over there. You are not increasing any of the other components, but you're increasing the weight component in this equation. So as a consequence of that, you will not be able to fly because you are not compensating with the lift part of it. You are not adequately compensating to lift.
Then there is another question. Are airplanes fixed wings or rotary wings? Because they have wings and propellers.
So airplanes are fixed wings and they're not rotary wings. The primary difference that you're seeing, even though a propeller is also a wing as we described over here, it is the reason, the definition between a fixed wing and a rotary wing classification would be that what component is producing the lift. Is your propeller, which is rotating, is not producing the lift. The propeller which is rotating is basically what you fundamentally call as an air screw. You know what happens to a screw when you put it into wood, right? You turn the screw, the more you turn it, the more deeper it goes into the wood. The propeller is doing exactly that, but in air. As you rotate this thing, you see this, because of the angle of attack of this thing, as you rotate this, it digs into the air and it pushes the wind backwards, which is what creates the thrust component. It pulls the aircraft into the wind or pulls the air backward. Again, as I told you, everything is relative. So between each other, you are creating velocity, and as you create velocity, you are able to put air on top of the wings. The wings are generating lift by virtue of the aerofoil section that is there. So the primary lift generation is happening by the wings, which are not rotation, and therefore fixed wing, normal airplane is a fixed wing and not a rotary aircraft.
Then there is one more question. My drone is also going vertical takeoff, but it does not hover. So what type of drone is this?
You will have to describe to me a little bit, why do you think that if it is able to do a vertical takeoff, what makes it not capable of hover? How do you define what is hover? You are able to generate a lift and you're able to balance all these forces. Lift, thrust, drag, weight. You're able to balance all these forces and stay stationary. If you're able to generate excess lift and compared to your weight, which is what is a vertical takeoff system, you are in a capacity to hover technically. What is not allowing you to hover is something that is not part of this classification. It must be some other limitation that is there on the design of your aircraft.
Can you elaborate what is the meaning of thrust?
So thrust is the force in terms of, in the aircraft concept, thrust is nothing but the forward force. So how do you generate the forward force? In an aircraft, you have the propeller. As your propeller is rotating, it is pushing the air backwards. So as it pushes the air backwards, the aircraft is pushed forward. Both are relative, as I've told you. So that is what is the thrust. Thrust is basically this component of force which is pushing forward. So thrust is forward, drag is backward, lift is upward, weight is downward, acting forces.
Okay, how do you connect a drone to a different drone if one drone is remote?
So will come not in the aerodynamics part of it, but it will be in your flight control, the control which is the remote control systems. These are an evolution again in themselves. You know, there were sabotage operations that were carried out many years just because of exactly what you are saying, the problem of, if at all, this used to happen among even aero modelers. As friends, we used to even play with our other friends. If they are flying their drone, or rather back then we used to just call it aero modeling, 15, 20, 30 years ago. Aero modeling, if they are flying their drone, we would turn on our transmitter when they are flying, turn on our transmitter, and then do some controls. Plane would do all kinds of things in the air and then it will fall down. So these are all the times of the analog drone. So you had nowadays in analog RC control. This is nothing to do with the control and the aviation in terms of its aerodynamics and other things. This is purely a communication systems and networking problem. Here we nowadays have something called as a pairing. If you are paired to your drone, that is with the digital transmitters, we get this, wherein you have a code. If at all the aircraft is receiving instructions from a controller, it will only accept instructions from one controller by ID. So this is what pairing, and this is, if you want to change the drone from in the current systems, computer system, then you'll have to change the pairing. There are, depending on the equipment, the procedure for pairing will be different.
Do we have hybrid type aero vehicles?
This, what I described to you, which is hybrid, this basically is a vertical takeoff, still flying with like a fixed wing. So this is also classified as hybrid. However, hybrid is a general word. So there are hybrid in different formats. There is hybrid in terms of your structures, that is rotary and fixed wing hybrid. That is what this you are saying. There are different types of hybrid. In today's contextual thing, a lot of hybrid in drones is hybrid electric and petrol. So it is the propulsion, the fuel itself is hybrid. So hybrid is a general word. Hybrid can be used in different contexts. Hybrid is also used for propulsion, that is for the fuel. You have most of these that you're seeing here are electric drones, right? But there are even petrol-driven ones. You have aero models that are petrol-driven or kerosene-driven, or sometimes what we use as nitro. That's basically methanol. We use that also. So depending on the type, what we are talking about, the hybrid will vary. Meaning of hybrid will vary.
Okay, I have a question. So we have to monitor the train, let's say at the line of control. How do you ensure that you are at a safe distance from the drone, whereas the drone is at the line of control?
Okay. So now, if the drone is at the line of control, there are, when you say safe distance, it depends again how much is the safe distance. You could be anything 200 meters away and then consider it safe as well, depending on the size of the drone over there. But there are applications today wherein you want to be sitting in Delhi and flying it in the line of control. So this is where this will now, let us broadly put it this way. Once you are able to control the plane remotely, then the problem of controlling the plane goes away, and then it goes into the domain of wireless communications. Totally, it no longer nothing to do with the drone itself. If I am in a position to today fly a drone via remote here, in theory, with nothing different on the drone side of it, in terms of the aerodynamics, the structures and everything, only with the electronics and the wireless communication systems, I can modify that to finally fly from across the globe also. I could be sitting in my house and flying it here, or I could be in America and flying it in Bangalore. Anything is possible finally. All that will go out of aerodynamics and it will go into communication and this networking setup. Also a very, very, very important topic, because while I'm talking today and I spoke more in terms of fundamentals, fundamentals are necessary for you to design the drones, basic understanding and everything, but remember that technology is an assembly of fundamentals. Everything that you know today, which is great technology, is basically small pieces of fundamentals put together to build complex systems. A lot of effort, lot of knowledge, lot of this thing will go into, especially the area that we are talking about, networking. Very, very, very important when you are getting into the professional systems. Because
One last final
yes.
question. Just as we have autonomous car, can we also have autonomous planes?
Yes, sir. And in fact, autonomous planes came before autonomous cars. And when I say autonomous planes, even to this day, even your regular aircraft, the passenger aircraft that we are going, all of them come with autonomous capability. The reason why full autonomous capability is not utilized on any of these systems is because you still want to have a human in the loop for the purpose of safety, because these are all man-carrying systems. If you really look at the aircraft and you see the pilot over there, all the pilot's necessity, technically, strictly speaking, though sometimes they want to be flying manually, it will fly, the plane will fly itself. The pilot need not be there. The pilot is always a safety pilot, literally. However, there are safety norms that tell that, even to this day, if you sit in an autonomous car, will you have the confidence or will you forget autonomous car? Let us say that if your friend is driving the car and you are sitting in the front seat, and if they're driving, if they turn the steering, hey, you put your hand and you turn the control, right? Why? Because you don't have confidence in your friend. If your children basically start driving, what will the parent do? Hey, proper, you turn properly, don't turn like that. You would have seen everything, but then also you will control it. Now imagine if you can't see somebody sitting there. You're so scared when somebody is sitting and then you say, hey, Sari, what's up? Drive properly. You tell. Now imagine you can't tell anybody also. What will happen to your... So that is why even today, even though there is a lot of autonomous control in the systems over there, there is not enough confidence or not enough courage to leave it fully to the computer. And for good reason. You have seen a lot of failures that have happened. You have seen systems that have failed. A lot of the crashes that we have had in the recent times is also because the computer thought it was more clever than the pilot. The pilot gives control, but the computer will say, no, do this instead. And it does something and it crashes. So a lot of the crashes have actually been because of computer thinking or system thinking it is smarter than the person. Things will change, but this is the current state of affairs.
I think this is the final question I'm thinking. How can we connect a camera to a drone and how can we make drone waterproof?
So how do you connect a camera to a drone? Again, is a electronics problem. We will get to that part as well. For that, we'll have to understand it is nothing. If you can have a camera in your mobile phone and your friend is seeing what you're doing WhatsApp call, technically that's also what you can put your phone on the drone. You can make a call to your phone in WhatsApp and you can see what the drone is seeing, right? So then that is the fundamentals on which you can do. You can have camera on the drone without any complication with existing technology. But the technology itself, if you want to understand, we will get to it slowly. But there are cameras that are available, which are in the market, which you can simply just put it. I don't have them here. If you people are so interested, which I've understood right now, I will bring all those equipment also the next time I'm here for a talk. So now here, you see, this is you said how to make it waterproof. This is an example of a water drone. This is, what is it? Simply put, it is lighter than the water. So it floats on water. It has got all these floats that you see over here. It will float on water. Again, this is not a complete one, but this will float on water. You will have a cover that is here, that is sealed. So the fundamental thing that you have to understand that when you're doing a water thing is the electronics portion of your drone have to be protected from the water. So you need something what we call as hermetically sealing. So whenever you have anything that needs to be waterproof, like if you look at this underwater drone, imagine this was a flying drone or anything. I told you that for this, I can't have your regular switch. I can't have your, how if you have seen your normal drone, you will have one connector, you will plug the battery. You will plug the battery and then it will start. But I can't do that here. If I plug the battery in underwater, water will go into that plug. The short circuit will happen and the system won't function. So you see, this is a system in which there is no water that has to go inside. No water, nothing should go in, nothing should come out. Airtight. No air also should go inside, no air can come outside. This is how this system has been designed. In that context only, when we design something like this, we have to think about other things. How do I turn it on and off? So if you want to understand this also, this is more on the electronics design and system design that we are going to get to, but I will talk to you about that if for your curiosity over there. For example, on this thing, for example, we have what is known as a reed switch. How many of you know what a reed switch is? You don't know what a reed switch is? A reed switch is basically two elements of metal sitting next to each other like this in a glass tube. Because this metal are magnetic material, it is ferrous material. So when you bring a magnet close by, because these two are like this, when you bring a magnet close by, they will come and touch each other. That's how the switch contact happens. You can, if you use a bimetal, have you guys used bimetal, have you people used bimetallic strips in your labs?
In the relay, we would have used.
So there operationally the requirements are different. Bimetallic strips are used for temperature-based switching. So that's used for temperature-based switching. Here it is magnet-based switching. So here, finally you are creating the contact between the two. Like this, there are many types of switches. Even here there is, if you want to start exploring, there are plenty of switches. There is a switch like this. If you tilt it, it will turn on. If you straighten it, it will turn off. You know how? Just imagine I have these two pins like this, okay? And I have mercury. What is mercury? Yeah, and it's in what form? It flows, no? So just imagine that if at all I have two pins like this and I have inside a bulb and I have some mercury in that bulb. If these two contacts come on top, mercury will be in the bottom. So these contacts will not be triggered. But if this ball rolls and this contact comes down, mercury where it will be always at the bottom only, because it is gravity. So it will always be at the bottom. If this ball rolls to the bottom, this mercury will come in contact. And this switch is closed. So this is tilt-based switching. So you have like this variety of switching, the technical concepts that you can build in. Here we use what is known as a reed switch inside this thing. So I moved a magnet as I showed you. And then I turn it on. I have the reed switch over here. I just bring it over here, it turns on. Again, I bring it over here, it turns off. Now there are many more things that you will need to know if you are in electronics. Yes?
Underwater drone, how can it be charged?
Good question again. Good question.
If we use the small sockets, the water can pass inside and short circuit may happen.
So there are two ways. Now in this particular drone, let me show you. You see this connector over here? This is closed, it's sealed by a cap. But if I open this cap, you have cables. So you can charge it with the cables. But the problem with doing something like this is that this you can do only when you are out of water. When you are underwater, this has to be closed. Like a tap, it has to be properly closed. So this is that. But is this the only way to charge? This has a battery inside. But how that battery will go down? Over time it will go down. How do I charge it?
So when it is used for security purposes, as you have told before, when it goes under the sea and it rounds, so how much battery is expected to have? How much charge?
That will be the total design. This particular thing is for about 2 hours of operation. But that is totally a system design. We can build systems according to the requirements over there. So we can spec this thing. But the question is, if the battery goes low, how do we charge? If the battery goes low, how do we charge? Now can you think what all you have seen charging?
Hydroelectricity.
Potentially, but difficult. Okay, for charging, we'll bring it out, let us assume. I showed you, we're bringing it out and I'm putting a cable to charge. How many of you have seen, do you not have your, anybody new modern mobile phones, you put it on something, it charges?
Wireless charges.
How? How? Beautiful, no? You bring it like this, it charges. Huh? Huh?
Do they charge through digital signals or something?
How? You just imagine. Yes. How many of you have seen induction cooking at home? Wireless heat. Beautiful. How? Wirelessly you are transmitting heat, no fire, but it's becoming hot. How? Yes. So now, if you want to do this, you have to start learning physics. Go back to your physics classes. Look at electromagnetic induction, how that happens. What happens during electromagnetic induction? Do you know your transformers? You've seen transformers on the roadside, no? Roadside transformers are there, coils. You've seen, no, on the poles sometimes coils. Have you ever heard of transformer blast? People have told you transformer blast. Why? Why does transformer blast?
Because it gives more electricity than it can hold.
Okay, one way to look at it. But what is more? How do you define more? The fundamental thing is,
Copper. So copper will have the more heat. It will absorb the more heat in that. When the power comes more, the copper will, limited to the more heat it will absorb. So it will more energy it will blast.
definitely your part right over there, but fundamentally you have to understand this thing that when you have electromagnetic induction, you also have heat generation. Electromagnetic induction will generate heat. Therefore, your transformer blast. But electromagnetic induction can be useful in many, many ways, including if you want the heat itself, like in your cooking, or if you simply want to transfer energy to your phone to charge it. So, think of all the different ways you can do things like this. So, remember that innovation is one thing where everything requires you to, you can ask stupid, but everything requires you to ask why? 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 Why is that? Why? Why does that happen? Why does this happen? The better your question, the more knowledge you'll actually, as you grow older, as you get more knowledge, the only thing that should change is the quality of your question should change, but you should always keep questioning. How does this happen? How does this happen? How does that happen? And then you start learning more. So that is where we get to do all these things. Yes, please.
Why do multi-rotor drones consume more power than a fixed wings drones?
Okay. So there are, we'll have to get into numbers to explain it in detail, but let me put it in very small, in simpler words. What is the area of this wing? You think, and this, both are roughly same weight. System, this and this are equally heavy. But what is the area of this wing compared to this wing? I told you the propeller is also a wing and it's generating lift. Okay? Isn't this area very high in compared to this one? That area will basically means that you are able to generate a lot less lift in a given area. In an area of, when it comes to a multi-rotor, the area is not this area, but it is this whole disk area. But in that disk area, only this much is producing lift. But you're consuming this much area. So therefore, your efficiency is actually slightly lesser, than your fixed wing aircraft over there. And there are many more things. We'll again have to get into more detail. This helicopter or any multi-rotor wing is so long, right, this propeller? When I'm moving an aircraft forward, the whole wing is facing the same relative velocity of air. Do you understand? But in a rotating platform, what happens? What is the speed here and what is the speed here? At this point, speed will be very high. At this place, the speed will be very less. Have you played in your childhood? Have you've been in those, in the park, revolving, there will be something, 4 people will sit and you can turn it. Where are you feeling the most comfortable? On the outer edge or in the center? in the center, right? Because in the outer edge it is throwing you away. Because the speed is more at the outer edge. The same thing happens over here. Even when, first of all, you have a smaller area, then you have non-uniform velocity, where you have maximum velocity over here, lift generation is high over here, but as you come to the center, the lift generation is near zero. Because once it comes here, there is zero, velocity is zero. So your lift generation also keeps decreasing as you come to the center. So the total lift generation of this will become less, and effectively that's where you have the energy, consumption, which is very high to finally push that much air. Finally, when you look at it in terms of your 4 components of lift and weight, drag and thrust, what do I need to do? How much weight is there? I have to give lift that much only to stay over, right? So I have to generate more lift for smaller area. So therefore I have to increase the speed, I have to increase the size of this wing, all these things for generating. So therefore effectively my efficiency comes down, while I get other advantages like vertical takeoff. Yes.
Sir, so in helicopters, I see their wings at the top which spin, but I have also noticed that at the back of, at the end of the helicopter, there is a smaller wing that is tilting. So what role does it play?
This one, right?
Yes, sir.
Very, very good question. I want 2 volunteers. 2 people come to the stage. Come here. Both of you push each other little. Don't push too hard, okay? Yeah, push each other. Come this side. Push each other. Now it happened, huh? Okay. Now you're stronger, no? You go push the wall. It's not moving. Just push like this and go. You moved back, but that didn't move. But when you pushed him, he moved. Why? Is it a fixed body? It is fixed relative, right? Is it a fixed body? So what is fixed? So it is fixed relative to what? Because there is nothing called as fixed in this world. The earth itself is one ball in the sky. In space, earth itself is one ball. It is also not fixed. So you can push the earth, no? So when you do push-ups, are you pushing yourself up or are you pushing the earth down?
We are pushing ourselves.
Okay, how did that happen?
By our strength.
Isn't mass playing a role here? Your weight. If you are a heavy person, he is a light person. If you push him, he will fall. If he is a heavy person and you are a light person, you push, he will fall. Okay? So this is for, now I told you about, for 2 people. Now do the same thing for a motor and a propeller. Think about it this way. This is what I told you. Now motor and a propeller are 2 components. Till now what you told, that wall is fixed, right? So it didn't move. Now I'll make the situation different. In a propeller, in a motor and a propeller which is hanging in air, you power the motor, what will happen?
The propellers will turn and the lift will be taken.
Propeller will turn, lift will generate. Why will the motor not turn? Why is motor not turning? Propeller, you said motor will stationary, propeller will turn, no?
No, motor will also turn together.
Both will turn.
Yeah.
Then what is the use?
It's a restless motor.
If I have a motor and a propeller and I power the motor and propeller both will turn, then where is lift?
Only the
Only the propeller will turn. I am asking you that only. If only propeller will turn, you are telling. But I am asking, why should the propeller turn? Why not the motor turns? But who is stopping? You said there it is fixed. In air, what is fixed? It is in air, no? Helicopter is flying. Helicopter is flying. When this is, you are saying that this fellow is giving power, this fellow is, rotor is turning, correct? But I am asking you the question, why shouldn't it be that if I hold this like this, and I put power, this will rotate? This should rotate, no? Why only this is rotating? It's free body. That you said wall, okay, fixed. Now what about this in air?
So because it will then so the back propellers are used to control that.
So, what I told you about your mass, who is lighter, will move far, right? Here, between these two, which is lighter? This is mass moment of inertia. This will move more, but this will also move. Just like if you push him, because he's light doesn't mean you will not go a little back. Even you will go a little back, but you will go less. He will go more because of his mass. So this is basically the same thing that happens in rotation. What you are talking in for linear, no, pushing each other, the same concept will apply for rotation here. In rotation, because this has lesser weight, mass moment of inertia, it is slightly different. We will get to the rotary masses. This is called as mass moment of inertia. This has higher mass, this has less mass. So therefore, when there is relative motion between these two, this rotates more than this rotates. First thing. But this will also rotate. To counter that, you have this back propeller. So what this back propeller has to do, if this speed increases, if the more power increases to this, more power has to increase to this also. That's how it is stable again. Another good reason for you to understand what makes helicopters so complex. You need this additional fan here. Because if you don't have this fan, this will rotate. You have seen in movies, no? The hero will shoot the helicopter over there. This is called a gondola, the bottom side. The gondola will start rotating and the whole thing will come down. You've seen in movies, no? That is because the tail has no longer functioning. So you have nothing to stop the gondola from rotating, so it will start rotating. Both will rotate and then it will essentially fall down over there. So that is basically why you have this thing. Okay? Now, good question, but I'll only follow up this question over here. If this, what we said, is happening here, what makes your quadrotor special? You don't have separate like that, no? You can sit down. You can go back. You understood the problem that they described? Do you understand the explanation? Why should, in a helicopter, why should the body not rotate and only the fan will rotate? For that you have a compensation with another fan in the back to prevent this rotation now. Because of this, this is another reason why quadrotors has become so popular. Quadrotors or multirotors like this one. This complexity is not there in that. But can you tell me why? Now, think about it this way. Again, I'm rephrasing this question. Here you have one body and one propeller. If you are rotating the propeller or relative to the body, both will effectively rotate. To compensate for this rotation, I am putting this fan over here. Okay? So now, apply your mind, bring it to this thing. You have actually already answered it without knowing that it is the answer for this. You already, in your question, you already told me that. Now apply this to, apply that to this. Same, let us bring the same problem from helicopter to here. These propellers are rotating. If the if this system is held in place, this is rotating, this is rotating. If this rotates like this, what will happen to this main body? It will rotate like this, opposite direction. Again, this is also rotating, it will opposite direction. This is rotating, it will go in opposite direction. This is rotating, this is opposite direction. So finally, if I'm in a drone like this, if I'm powering up the system, these are rotating in one direction. This whole net, because each one is creating that rotation force, in net should also rotate in the opposite direction, no? In this drone. But it doesn't happen. Why?
Maybe because each propeller is compensating the another one. Because two are actually rotating in a clockwise direction and the other two are rotating in anti-clockwise direction. So maybe they're compensating each other, already balancing the weight.
You're absolutely right. Isn't that what you said? You remember your question? You talked about the clockwise and the counterclockwise. It is exactly for this particular reason that we have opposites running in one direction. Clockwise or anti-clockwise, you can interchange it. These two are in one direction, these two are in the opposite direction. Okay? Now, since we are again on this topic, let me again expand it further. I just now showed you saying that these two are in one direction and these two are in the opposite direction. Now tell me, why is it that our order? Why can't I have these two in one direction and these two in opposite direction? Pardon?
The moment of speed will be decreased.
How? All of them are rotating at the same speed.
Actually, ಗಾಳಿ ವಿರುದ್ಧ ದಿಕ್ಕಿನ ಕಡೆಗೆ ಚಲಿಸುತ್ತೆ.
Hmm?
ಗಾಳಿ ಯಾವಾಗಲೂ ವಿರುದ್ಧ ದಿಕ್ಕಿನ ಕಡೆಗೆ ಚಲಿಸುತ್ತೆ. ಒಂದ್ ಕಡೆಯಿಂದ ಶಕ್ತಿ ಬಂದ್ರೆ ಇನ್ನೊಂದ್ ಕಡೆಯಿಂದ ಯಾವ ಕಡೆ ಗ್ಯಾಪ್ ಇರುತ್ತೋ ಆ ಕಡೆಯಿಂದ ಚಲನೆ ಮಾಡುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ಆ ಡ್ರೋನ್ ಅಲ್ಲಿ ಎರಡು ಕಡೆ ಇಟ್ಟಿರುವಂತದ್ದು ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ಸ್. ಸೊ ವಿಂಡ್ ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೋಗುತ್ತೋ, ಎನರ್ಜಿ ಯಾವ ಸೈಡ್ ಇರುತ್ತೋ ಆ ಸೈಡ್ ಇಂದ ಎನರ್ಜಿ ಫ್ಲೋ ಆಗುತ್ತೆ.
No. Center of gravity? Gravity is not changing because there is no mass addition or deletion.
I think it might be because of angle of attack.
Okay, why do you think it is angle of attack? Though the answer is no, I want to know why you ask, why you think it is. Why do you think it's angle of attack? Yeah?
Because if we want to tilt like this, we have to increase the weight this side. So when this rotates in anti-clockwise, so this can compensate that.
You are absolutely right, wrongly phrased. Absolutely right. Your same last problem. You just didn't know how it's connecting here.
In the drones, if you want to turn it left or right, the two propellers will be turned anti-clockwise and other two propellers will be straight. If you want to turn it left side, all the two left side.
Let's define these things. When you say left, are you talking about this left or are you talking about this left? Like this, tilt, okay.
If you want to tilt the drone, the two propellers, that will be little bit slow covering the movement. When the same, if we do it on the both side, the drone will not move.
Okay.
It will be stable. It can fly up, but it can't move this side or this side. It can't even go front or back.
Okay.
It will just be like, it can come up and it can stay there only.
All of you are getting it. You're just not nailing it. Okay, so let me bring this. Let us understand this with a little bit of terminology also, because it is convenient to converse in those terms. So if you look at, these are all terminology that has come from the fixed wing. In an aircraft, you have this motion of the aircraft, which is known as tilt. Pitch. This is pitching. Up pitch, down pitch, then this is roll. Okay, so you have a left roll and a right roll. This is roll angle, pitch angle. And this rotation is yaw. That is a flat rotation. Okay, so this is just terminology. We will get, you know what, terminology is only for conversation. In your head, you could have no terminology and imagine all the concepts. So terminology is good for communication, so you should understand it. But that should not become like, you don't know this term. No. That knowledge is more important than the terminology. So we'll get to the terminology. It's useful to communication. Now, let's talk about this quadrotor. Why do we do it in opposites like this? What are the motions? The same motions that I showed you for the aircraft are also desirable on a multi-rotor system. You want it to pitch forward so that you go. You want it to pitch backwards. You want it to roll left, roll right. You want it to go up, go down, and you want it to yaw. These are the degrees of motion, what we call. So there are these many degrees of motion on a multi-rotor system, helicopter system. So if it's very clever for us to place them in opposite leg. Now let me ask you this. Let's assume that it is stationary in hover condition. Hover condition for numbers, just arbitrary numbers I'm going to put. Each of they're put in opposite directions in such a way that these two are clockwise, these two are anti-clockwise. Let's assume. All rotors are rotating at 100 RPM, 100 rotations per minute. 100 RPM essentially will give you 100 RPM will essentially give you the kind of lift that you are generating. It is stationary. Okay, agreed? This is an assumption that we are starting on. If I want to lift this thing, what will I do? Increase the speed, right? Okay, increase instead of 100, I will make it 120 RPM, it will start rising up. Now because why? In that 4 equations that you are seeing on that, lift is higher than weight. So it is rising up. The moment I rise to the point where I have enough, what will I again do? Again I have to bring 100 RPM back to 100. Because it has to stop over here. Alright? It's not actually literally 100, it will be little 102, 103, little more than that, because air is also becoming thinner as you go up. Okay, but we'll get into detail later. Just assume that air is now normal. So this is for lifting. Everybody got it without any doubt, right? So increase the RPM, it raised up. Now if I want to tilt forward, what will I do?
The front motors increase the RPM.
Front both will increase or decrease? I want to move forward.
It will increase and the back two will increase.
It back to will increase, no? Okay. Now, when I'm increasing the front two motors, this is clockwise, this is anti-clockwise. This is clockwise, anti-clockwise, correct? So I am decreasing one anti and one clockwise motor. I'm decreasing them together and I'm increasing one clockwise and one anti-clockwise together up. So what happens to the torque that we spoke about that time? Will anything change? Because one anti is increased, one anti is decreased. One clock is increased, one clockwise is decreased. So net torque, this rotation will not happen. It will be stable in this axis because these two are opposite. Now imagine, I asked you why this should be in opposite places. Now imagine these two are clockwise, these two are anti-clockwise. Just now put your mind to it. Now to go forward, I have to reduce this throttle and increase this RPM. I will reduce this RPM. Both clockwise have decreased. So anti-clockwise, that means if this is clockwise, anti-clockwise is my rotation, compensation. The anti-clockwise torque that is generated on this frame because of this has decreased. Because these two have decreased. Are you following what I'm saying now? These two are clockwise. If these two are increasing, the anti-clockwise motion that is there on my main body frame is increasing. Are you able to understand what I said? Now, if these two are not compensated, the torque is not compensated, what will happen to the whole frame in this axis? It'll start rotating, no? Now, unintended motion. You wanted to go forward, but what is happening? You are going like this and then you are rotating like this. Now, think about it if I were wanting to actually do a rotation like this. Let us say that I want to actually do a rotation clockwise. I will reduce the throttle on these two and I will increase the speed on these two. So the RPMs will change. Now counterbalance will not be there. Why? These two are both in reducing, these two are increasing. These are anti-clockwise, these are clockwise. So counterbalance is not there right now. So what will happen over there? This will, when you are trying to rotate it like this, it will also go down. So all this will come as you start advancing more into it. As your questions are coming, I'm answering to you, but these are all will start getting more and more advanced. Is there anything more? Shall we?
Sir, I had a question. Sir, is the drone, how does the drone know its height if the pressure keeps changing?
How does the drone know its height if the pressure keeps changing? Let me reverse the question to you. How does the drone know its height if nothing is changing? If nothing changes, how do you know what is? If I am moving from here to here, I know that I am moved because everything around me has changed. This thing has gone backwards. So I know that I have moved forward. In fact, it is the very fact that there is pressure change in air which actually helps me determine my altitude. If there was no pressure change, I wouldn't know how high I am. By measuring the pressure is how I know what is the height I am at. Yeah.
Thank you, Kishore sir. It was a wonderful session, and I am awed by the kind of knowledge which we have brought in the last approximately 2 hours. And it's like dil maange more, but of course you have to bring this to an end. And I feel that this is just a kind of a starter for everyone who are watching through YouTube or who are sitting here. Almost 40 students from Tapovan are sitting here. So this is just a starter for you, and I'm sure you will go through the ATL module which we have. So we have a drone kit as well as a ATL module in our Atal Tinkering lab. So you can have a look at that. And plus you also have availability of Kishore sir. You can reach out to him through his email ID of his organization. And I also request that keep your mind curious enough to ask. Like he said, that until unless you ask questions, you will not get your answer. And those may be as silly as what it may be. I asked also some silly questions to him, so I'm sure he is okay with that. So please be curious, ask questions, and as he said that this technology is still not explored. So for example, I'm first time knowing that there is a water drone, and through water drone, what all things can happen. You can just imagine so many things. And I've seen in some of the colleges, people are researching in water drone, so that could be one. And as far as the aerial vehicle is concerned, that anyway is there, and you can explore so many variants which he talked about. So thanks a lot, sir.
Thank you, sir.
For this wonderful session. And now I request Kiran sir to give vote of thanks. He is the brother of Kishore sir, and I request him to give.
Both are trustees,
Yeah.
school trustees.
Hello. So I would like to thank Kishore for the wonderful session. I learned a lot personally. Even though I'm his brother and we end up talking a lot, this is still, some parts of this are still new knowledge for me as well. So if it was new knowledge for me, despite the fact that I have, ongoing conversations with him every day, I can imagine how exciting this must be for everyone else as well. So I hope the students enjoyed this. We also had about 40 plus viewers online live streaming, and there's been a constant chat as well there. So for all of you on the live stream as well, if you have any do is make people like him talk. And in general, like a lot of people who are doing work never get the opportunity to talk about it, and also don't get an opportunity to know how good it is, because usually nobody looks at the details and asks them difficult technical questions and says, but what about this? What is actually interesting in what you have done that others have not done before? And so I run a company where I look for people who are doing interesting work and need proof that it is actually interesting, because they want to be sure that they are not over imagining the quality of what they do. And so I get them to talk to people doing similar work in other companies and confirm what the work is worth, what improvements it can have, and so forth. And then we try to get them to make public presentations about it after that review, so that everybody else can benefit from that learning. So, and as part of making that possible, one of the things that I have been working on is just building this live streaming system that we are using today, the camera that you see there, the machine that's over here that's controlling the live stream. So that's something that I have been working on as a product to make this much easier to do repeatedly for anyone to live stream an event. And today in particular, I'd like to thank Lochan, the volunteer who's doing watching. Come in, Lochan. So every time we saw the camera move, switch angles and whatnot, it was Lochan behind the controls, doing it wirelessly. So what do you think of this?
It was a grateful experience to me.
You are operating a drone.
Yeah, just a drone without wings. Thank you everyone, and thank you to everyone as well.
And I have to come here. I definitely have to introduce our ATL coordinator and also school administrator, Agnes Swarna ma'am, who is silently behind every activity that is happening in the school. Totally, after Sharma sir's demise, she has become the backbone of the school, and definitely multitasking she is doing, technology one side, finance other side, and all other activities. And I really thank you, Swarna, for supporting the school so well. And definitely, hip hip hooray to the program. Can you say?
Hooray! Hooray! You don't have to be so quiet also.
Thank you. I really have to thank fundamentally AIM, then ATL, and then now the activities really began. It was all till now our own personal struggle. We were like searching in the darkness how to go about. From here we have come a long way, and really thank you, Deepesh sir, for this concept of cluster and then giving opportunity to everybody. I'm sure all of you are benefited now. Yes, how many of you want to take up immediately electronics and drones and other things? Now already hands up, I see. So it has kindled your original idea or ideation, you all know, design thinking, you all know, problem solving, you are already at that point, designing your own things. Thank you so much. Now you are moving ahead further to create, and the next session, your own drones, and then flying also. So that will be a series we are going to have in this month. Thank you. Thanks once again to definitely the government of India. Thank you. Wonderful concept of giving schools ATL. That is the reason all this is happening in the schools. Thank you so much. So I really thank the central government for this concept.
One more Thanksgiving is pending. I would really like to thank our student council members. They are, the effort they put into arranging everything, and Disha came very early today and she helped with arranging and all yesterday, everything, arranging things. Not only students, teachers also, but student council, you are doing a great job. Thank you, children. Very much.
It's closed, no?